Okay, so here we are in section 5.5, homework. Now this section is we're gonna use some software online. I'll explain. So here's the actual question. They're giving us this function, and they want us to find all zeros of the function. Now, what does that mean, all zeros? It means all places where the function hits zero. Now here's a graph of the function. And you can see that it hits zero right there at this point, right there at this point, and right here at this point. So that function has 3 zeros. There's the answers already for us. But I want you to know, when you do the homework on Canvas, it's not going to give you this graph. No graph given on the Canvas homework. It won't give you the graph, and it won't give you the answers, obviously. So where did I get the graph? I got the graph from Desmos. So here, let me show you. You get the graph at Desmos, DESMOS.com. So that's a free graphing program that's available online, no charge, super easy to use. You can use other online programs to graph, or a graphing calculator if you want. All these options are fine. I'm just telling you probably the easiest way is Desmos.com. Let me show you exactly, because again, they don't give you the graph on the homework, and we need that graph to help us solve this problem. Let me show you. So here's an actual snapshot. So here I am. This is Desmos.com. This is a screenshot from where I went to Desmos.com. And then I just typed right over here. There's the function we're looking at, the y. I think they had f of x. It doesn't matter. I just said y equals, same thing. Y equals 8x cubed minus 38x squared plus 5x minus 25. And then automatically Desmos graphed it. It just does it automatically as you type it in. Super easy to use. And I grabbed just a snapshot. I think I just went like that on my computer and just took a snapshot and put it next to the question. So what you're going to have to do as you're doing this homework, section 5.5, is for every problem you're going to have to go out to Desmos.com or any other graphing place or your graphing calculator and type in the function over on the left, y equals, you don't need to use f of x, you can just type y equals the function, and it will graph it for you automatically. And then we'll use that graph to help us find all the zeros, which is what we're doing in this section. This section is all about finding all the zeros. When you type it in, by the way, you have to, see I typed in 8x cubed, I did 8x, and to get the third power, you go up arrow, third power on your keyboard, minus 38x up arrow squared, plus 55x minus 25. So the powers are with the up arrows when you type it in to the upper left corner of Desmos, and then it graphs it for you automatically. Then you look at that graph, and what we're looking for is zeros. We're saying, where does the graph hit? So we're looking at this point, and this point. Let's go back now to the one I put on the snapshot next to the problem. So here it is. So here's question number 1. Again, I got it at Desmos.com. So at Desmos.com, we've got this graph of this function, and we're trying to find all the zeros. So here, let me erase all this. So I want those 3 places. So right there, so this is 1, 2, 3, 4, and 5, right? Boom, look, it hits right at 1. See, that's one of our answers. And then it hits somewhere a little bit to the right of 1, and then somewhere between 2 and 3, it looks like about 2.5. So all we can tell for sure is this one is at x equals 1. That one's right on the button. So when you graph at Desmos.com, just take the 0 that's real obvious, the one that you can see super clear. That one right there, it hits at x equals 1, clear as day. The other one, I don't know. It's a little bit to the right of 1. This one, it might be 2.5. I don't know. It's somewhere between 2 and 3. Those are not as clear. But the one right here at 1, that hits right at 1. So we know that's the x equals 1. So start with that one. So number 1, first step is you graph at Desmos.com, find a clear 0. Find a clear 0, x equals 1. So there's my first clear 0. Step 2. Now what are we going to do? How are we going to take it from here? Well, let me explain to you what we're doing. We're basically trying to take this function and break it all apart. Imagine with me, so we have this big old function right here, and we want to break it all apart. We know that this function, y equals, or f of x equals, is x minus 1 times something. Now, how do I know it's x minus 1? Well, remember, whenever you put a number next to x in the parentheses, it's always the opposite of what it equals on its own. So we found a clear, obvious 0 right on the graph, right there, x equals 1, so x equals 1. That means the opposite of that in the parentheses next to x. It's always opposite when you factor it in the parentheses next to x. So if that had been -1, then this would have been +1. It's always the opposite of the actual number x equals. So x equals +1 was the 0 on the graph, +1 right there. So -1, opposite, is what goes in the parentheses. Okay, so how do we find out what goes in this other parenthesis? We're going to do it by dividing. Let me show you. What if I had the number 30? Let me go for example. What if I had the number 30? And I said, hey, I'm going to give you a number that divides, divides in evenly is 2. So what if I told you it's 2? So then you'd go, okay, so this must equal 2 times something, right? 2 times something. 30. 30 must equal 2 times something, because if you found a number that divides in evenly, and that's what we've got, excuse me, with the x minus 1 here. We're doing the same thing with letters as you would with numbers down here. So if you looked and you said, okay, well, I've got 30, I know 2 goes in. How would you find 2 times what is 30? I mean, I know you know off the top of your head that it's 15, but what if it was, a harder number and you weren't sure? How could you find 15 is the other thing 2 multiplies by to give you 30? You would have to divide, wouldn't you? You would have to long divide. You would say 2 goes into 30, and you'd go 1 times 2 is 2, subtract 1, bring down the 0, 2 goes into 10, 5 times 2 times 5 is 10, goes in evenly, right, 0 remainder, you go, oh, 15, 2 times 15, right? That's how you would find, you would divide. And so that's what we have to do here. And then what would you do from there? After you had the 15, let me do it over here. You would say 30 equals 2 times what? And how you would find that thing is you would divide 2 into 30, and you would get the answer 15. And then you would bring that back. So that's exactly what we're going to do, but we're going to do it with x's instead of with numbers. But it's the same concept, right? Instead of a 30, we have this big old function here, 8x cubed minus 38x squared plus 55x minus 25. That's my y. That's my function value. So I'm going to break it down. I know it's x minus 1 times something. Well, what? Well, how you find what will multiply x minus 1 times what will go back to be the 8x cubed thing is you divide x minus 1 into the 8x cubed minus 38x squared plus 55x minus 25. All right, so we're going to do that with synthetic division. Remember synthetic division? We'll do that right here. Now, when you put the 1 out here, remember you just put the regular one, what it was right there. It's only opposite in the parentheses. Everywhere else it's normal. It's normal x equals positive 1 right here, normal x equals positive 1 right there. It's only opposite in the parentheses. Okay, and so then you put the coefficients. The 8 goes here, the minus 38 goes here, the 55 plus 55 goes there, and the minus 25 goes there. This is going to make that 55 a little bit better. Okay, and then remember how this works. You bring down the 8, and then you go multiply 1 times 8 is positive 8. Add them up, and that'll become minus 30, right? And now you take the 1 and you multiply. We're doing synthetic division. 1 times minus 30 is minus 30. Then you add those up. 55 minus 30 is 25. And then you multiply again. 1 times 25 is 25. Add them up. 0. Remember that last spot is the remainder. So we got a 0 remainder. Just like over here, we got a remainder of 0. Why? Because 2 goes evenly into 30. That's what it means when you get a 0 remainder. There's nothing remaining. It goes in perfectly, evenly. So that means that 1, or x minus 1, opposite in parentheses, divides evenly into 8x cubed minus 38x squared plus 55x minus 25, our function. And what does it leave left over? These guys. This is 8x squared minus 30x plus 25. Does that make sense there? That tells us what multiplies. Just like the answer of 15 we got comes over here. Right? We're breaking down the 30. Now we know it's 2 times 15 because 2 goes in evenly. 0 remainder, 15 times. 2 times 15 is 30. Same thing here with this big polynomial function, 8x cubed, etc., etc. It's x minus 1 times 8x squared minus 30x plus 25. Now, we have another step to go. Right here, same thing, right? You would need to, the 15 would break down to be 3 times 5. And then you would have the 30 all factored down. Well, that's exactly what we're going to do here now on step 3. Step 3 is use the quad for the 8x squared minus 30x plus 25. You're going to use the quad or factor. I'll say it either way. You can either do the quad or factor to break down that last part. Just like we broke down the 15, we factored it 3 times 5. We're going to break down this 8x squared minus 30x plus 25 that's right here by the quad or by factoring. So now let me go to a fresh screen here to do it. 8x squared minus 30x plus 25. All right. So this is number 1. 8x squared minus 30x plus 25, right? Wasn't that our number? Let me go back and double check. 8x squared minus 30x plus 25. I'm going to break it down. All right, so now I'm going to do the quad. Remember the quad, negative b plus or minus square root b squared minus 4ac all over 2a. This is a. This is b here. This is c here. Okay. Now let's plug in the stuff. So negative b, what's b? Negative 30. Negative 30 plus or minus the square root of b squared minus 30 squared minus 4 times A, which is 8 times C, which is 25 all over 2A. Okay, so we have that all broken down. Now let's use our calculator. So here we have two negatives, makes it positive. So bring it down here, positive 30 plus or minus square root of 30 squared, 900 on your calculator, minus 4 times 8 times 25. 4 times 25 is 100. 4 quarters is $1, right? On 100 times 8, 800. All over. Oh, 2A. I forgot to put in the A there, huh? The A should have been 8, huh? So this would be 16. All right. And so where does that go? So that's equal to 30 plus or minus the square root of 100 over 16. So that's 30 plus or minus 10 over 16, right? Because square root of 100 is just 10, no more root. Remember, after you do the square root of 100, it vanishes when it becomes a 10. And so what are the answers there? It's 30 plus 10 over 16, or 30 minus 10 over 16. So we break it into the two different cases, 30 plus 10 over 16 or 30 minus 10 over 16. And what's that? That's going to be 40 over 16, and then we reduce that, divide top and bottom by 8. So that'll be what? 5/4? No, 5/2. And then the other one is going to be 20 over 16. And then divide top and bottom by 4. It'll become 5/4. And that's the other answer. So those are our two answers from the quadratic formula. We broke down this 8x squared minus 30x plus 25, and it became these two answers, 5/2 and 5/4. There we go. Let's go back. So we get 5/2 and 5/4. So now we have all the answers, all the zeros are 5/2, 5/4, and the one from the beginning, the very first one we got right off the graph, 1. And those are the three answers they want from us in the homework. Any order, you can put those in any order, it doesn't matter. Just separate them by commas. So there they are. We found the 3 zeros. Those are the 3 places where the graph hits 0. We can see the x equals 1. What is 5/4? If you divide 5/4 in your calculator, it's 1.25, because it's 1 and a fourth. And 5/2 is 2.5 or 2.5. So 1.25 and 2.5. You can see this one right here. Let me get rid of that. This one right here is just a little more than 1. That's the 1.25. That's the 5/4. And then the other one here, that's the 2.5, the 2.5. So it's right, isn't it? These are the 3 places where this function, this 8x cubed, etc. function, hits the x-axis. Those are his 3 zeros. Those are the 3 places he is at a height of 0. So how did we get it again? Step 1, we graphed it at desmos.com to find a clear, obvious 0, x equals 1. That was obvious. The other ones were not as obvious because they were not right on a whole number. So we found the obvious clear when x equals 1, and then we wrote opposite in the parentheses, x minus 1, did long division, or synthetic division, and got the other remaining part, 8x squared minus 30x plus 25, kind of like starting with 30 and 2 goes in, and then you long divide and you get 15. Then we broke 8x squared minus 30x plus 25 down with the quad, and we got 5/2 and 5/4. So that gave us all 3 answers. Now the other thing you could have done, I said you could do the quad or you could factor. Factoring's quicker, but you have to be a really good factor. And I know it's not something most people are really comfortable with and real good at this point in your math career. If you keep going, you will be. You'll be super good at factoring. You'll be able to do it quicker than the quad. But so I'll show it just in case. You could factor. Here's the or. I'll say or factor 8x squared minus 30x plus 25. How would you factor? Well, that's where you just write the two parentheses, and you go, what multiplies to be 8x squared? Well, you'd want to go with 4x and 2x. You might think, well, isn't it 8x times x? It could be. It just sort of depends. It's usually numbers closer together, like 4 and 2 are closer together than 8x and 1x. So I'm going to go with 4 and 2. And it's going to multiply to be 25 back here. The back numbers have to multiply to be the back. Be 5 times 5. Now, what signs do you need? Well, these two and these two are going to make the middle minus 30x. So you want minus on this guy and plus on that guy, because that'll make this minus 20 and this plus. Oh, no, I'm sorry, you want minus on both. Well, minus on both. Then both minus 20 and minus 10 will make minus 30 in the middle. Now, that might be a little rusty to you, all those little details I did super quick. I know that's usually confusing for most people. You could check it to prove it's really right. If you were to multiply these, what would you get? 4x times 2x, 8x squared. 4x times minus 5, minus 20x. And now the minus 5 will go to both. That'd be minus 10x, right? Minus 5 times 2x. And then minus 5 times minus 5 plus 25. See how these two in the middle will combine to be minus 30x? See how it is indeed the factorization, the correct factorization of 8x squared minus 30x plus 25. So if you get that, then let me erase the check here. That just proved it's true. So now that you, okay, well, I've got it factored, but how does that give me my two answers? Well, what that means is remember, these are zeros. We're finding zeros. So you would have to set each of these equal to 0. Because we're saying, where does this thing equal 0? What are the zeros? So then you would jump over the 5, and it would be 4x equals 5, positive 5, right? When the negative 5 jumps to the other side, it's positive 5. See, what we're setting it equal to 0, because we're trying to find zeros. And then you would divide by the 4, 5/4. See, there's our 5/4 answer. This one, jump the 5 over, and then it becomes a positive 5 when the negative 5 jumps to the other side. Then divide by 2. See, there's our 5/2 answer. So, and we already had the 1. So you can get them all by factoring, but most people will prefer the quadratic formula. So there we go. It's all coming from Desmos. Let's go to number 2 here. So again, we'd have to do step 1 up here. The graph would be at desmos.com, and you would find an easy or a clear, let's call it a clear 0. So what's a clear 0? This is 1, 2, 3, 4, 5. Boom, right there at 4. It's clearly hitting at 4, and we already have the answer, so we can see it's going to be 4. The other ones aren't as clear. This is somewhere, negative. This is somewhere positive, maybe a half. We can see up here it's negative a third and positive a half. But we wouldn't be 100% sure. But the 4, we're 100% sure. Smack dab right at 4. That's a clear 0. So we start off with that. X equals 4, that clear 0. So now step 2 is we divide. So synthetic division. So I'm going to do synthetic division. Put the 4 out here and put the function inside. 6x cubed minus 25x squared plus 3x plus 4. And then let's do the division. Bring down the 6. And here we go. 4 times 6 multiplies to be 24. 24 minus 25 is negative 1. Next step. Multiply 4 times negative 1 is negative 4. 3 minus 4 is negative 1. And last step. 4 multiplied by negative 1 is negative 4. Add them up. 0. That's the remainder. 0 remainder. That means it goes in evenly. And what's our answer? It's these guys right here. 6x squared minus 1x minus 1. So that's what's left. So now we can either factor that or we can do the quad. I'll dive in. So step 2 is to divide. And so this is what's left on the top. So far, in fact, let's do it this way just to be more clear. What we're saying is we now have y equals this times, and then this x equals 4. Remember, that's x minus 4, right? It's the opposite whenever you put the parentheses next to an x, next to a single x. So there we go. So now, we're breaking down this original 6x cubed minus 25x squared plus 3x plus 4, which we're calling y, or f of x, whatever, equals 6x squared minus x minus 1 times x minus 4. We know it does because we know those multiply to go back to this because we just divided and got that quotient. Okay, now how do we break down the rest of it? How do we break down this part? It's the quad. So step 3, you do the quad. So that's going to be, let me see, maybe I'll squeeze it in here. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is my a, b, and c. So what do we have? Bring it over here. Negative b, negative 1, plus or minus the square root of b squared, minus 4 times a times c all over 2a, which equals, so the two negatives here become positive 1, plus or minus the square root of 1, this minus 1 squared is positive 1, negative 4 times positive 6 times negative 1. You just count the negatives. Notice there's two negatives there. It's going to be positive, and 4 times 6 is 24, times 1 is just 24. All over 2 times 6, 12. So that is 1 plus or minus the square root of 25 over 24. And that is, what's the square root of 25? It's just 5, right? Square root of 25 is just plain 5, and the root vanishes. Remember, when you root something, then the root vanishes. Okay, so we have two options then. We have 1 plus 5 over 24, or 1 minus 5 over 24, right? Doing the plus and the minus options. So this is 6 over 24. Reduce that. Divide by 6 top and bottom. That's 1/4. That's our second answer. And then now for the other one. This is negative 4 over 24. Reduce it. So divide by 4 top and bottom. That's negative 1. Whoops, I'm messing up here. This 24 should be 12. I don't know where I got 24 all of a sudden. Sorry about that. Let me go back. This is all messed up, isn't it? This should be 12. All right. Just showing you how easy it is to mess up. I'm kidding. This was not my plan. All right, 12. Let's go back. It should be 12. I don't know why I made that 24 down there. So it's 6 over 12. And then you can reduce 6 over 12. Divide top and bottom by 6. You get a half. Or 1 minus 5 over 12, which is minus 4 over, now I'm writing 13. I'm just going crazy here. Over 12. And then reduce that, divide top and bottom by 4. And this equals minus 1/3. Okay, so we got our answers then. So the first answer we got up here was x equals 4 from the graph at desmos.com. So 4. And then our other two answers we got out of the quadratic formula, a half and minus 1/3. There they are. Those are the three places. Right here, this must be the minus 1/3. See, it's not even all the way to -1 there. And this is the half, and this is the 4. The three places that that function hits 0. The zeros of that function. X to the third power function can have at most 3 zeros. All right, let's try number 3. Same kind of steps. Step number 1. Graph at desmos.com. So you graph it at desmos.com and get clear 0. So here's the graph. I've already graphed it at desmos.com and got for us a snapshot from that graph. Where is there a clue? This looks like it's something close to -1, but it's hard to tell. This is 1, 2, 3, 4. It looks like it's hitting twice here. You'd have to blow up the graph of Desmos, but I think it's hitting right there and then straight on 3. So there's a straight on 3, and then there's something just a little less than 3, it looks like. Let me kind of put that back there. There's right on 3, and then there's something a little less than 3. So I'm just going to take the one that's clear. Right on 3, x equals 3. That's a clear 0 from the graph, clear. Step 2, divide with synthetic division. So you put the 3 out there, and then you put the coefficients of our function. What are the coefficients right here? 1 and -5 and 4 and 6. And then bring down the 1 and let the division begin. So 3 multiplied by 1 is right there, 3. -5 plus 3 is -2. Whoops, going for the wrong thing here. Next I'm going to take that 3 and multiply. 3 times -2 is -6. 4 minus 6 is -2. Last step, 3 multiplied by -2 is -6. No surprise, 0 remainder. That tells us that the 3 goes in perfectly and that the 3 really is a 0. We were reading that graph correctly. That's exactly a 0 because it goes in with 0 remainder. It goes in perfectly, which means it's a 0. 0 remainder means it's a 0. Okay, so now on step 3, so now right now we have the function y equals, what are the coefficients that are left? 1x squared minus 2x minus 2. And x minus 3. Remember, opposite of positive 3. Whenever you put something in parentheses next to x, it's the opposite of the real number. So it's minus 3. So we have the function broken down that far, so far. And now we're going to break this part down with the quad. So here we go, quad time. It's always step 3, negative b plus or minus the square root b squared minus 4ac all over 2a. So we have here's the a, here's the b, here's the c. So negative 2 plus or minus the square root of b squared minus 2 squared b squared minus 4 times a times c, which is -2 all over 2a. Okay, what's that? So we got double negative here. You know that's going to be positive 2. Let me change the color so it's clear. So positive 2 plus or minus the square root of -2 squared is positive 4. Minus 4 times plus 1 times minus 2. Remember, count the minus signs. 2 negatives, it's plus 8, isn't it? All over 2. So that is 2 plus or minus root 12 all over 2. Now, we can't square root 12. At least it won't be a nice clean whole number. How do we deal with the square root of 12? Remember, I'll bring it over here. Square root of 12, remember you break it down. 4 times 3, 2 times 2 times 3. Those are the pieces of a 12. So, in other words, the root of 12 is the root of 2 times 2 times 3. And what do square roots do? 2 for 1 deal. But by the way, this is a 12, right? 2 times 2 is 4. 2 times 2 is 4 times 3 is 12. That is a 12. Square roots do a 2 for 1 deal. 2 2's inside, 1 2 outside. So 1 2 on the outside, 1 3 left on the inside. So 2 root 3. So square root of 12 is 2 root 3. So this is 2 plus or minus 2 root 3 all over 2, that root 12. Okay, let's bring it over here. How do we simplify that? Can I cancel like those 2's like that? Well, not just those 2's. Remember, the plus or minus here is glue. It makes these guys be glued together in a package deal, right? Costco glue, the plus or minus is like Costco glue, gluing them together. So as long as you buy the whole package, though, Costco will sell you the whole package. You just got to do both of them. So basically, here's the deal. If all 3 of those outside the root numbers, if they're all divisible by 2, let me put it back the way it was, then, or whatever number, you can do it. They have to be all 3 divisible by the same number, and they are, right? They are in this case. This number, this number, this number. Divide by 2 leaves a 1. Divide by 2 leaves a 1. Divide by 2 leaves a 1. So it's 1 plus or minus root 3 over 1. We don't need 1's on the bottom. Dividing by 1 does nothing. So our answers are 1 plus root 3, comma 1 minus root 3, and the answer we had from the beginning, plain 3. Those are the 3 answers. Those are the 3 zeros. Everybody see how this works over here? If all 3 of those numbers are divisible by the same thing, then you do it. Now, if one of them couldn't, like if this had been a 3, for example, he's not divisible by 2, then I would do nothing. I would just stop right here. I couldn't divide anything. It's all 3 of them or nothing. All 3 have to be divisible. All 3 of them have to be divisible by the same number. All 3 of them were divisible by 2, so I divided them all by 2. Got 1 plus or minus root 3 over 1. Divided by 1 does nothing. Get rid of that. So it's 1 plus root 3, 1 minus root 3, and the original 3. That matches the answer right there. Those are the 3 zeros. Those are the 3 places. If you did this on your calculator, 1 plus root 3. Let me see, I'll do it on my calculator too. See, 1 plus square root 3. If you're interested, that's 2.7, 2.73, blah, blah, blah. And 1 minus the square root of 3 is negative 0.73, blah, blah, blah. So this looks like negative 0.7, doesn't it? And this looks like 2.7. And, of course, that is 3. So those are the 3 places where that function hits 0, has a height of 0. Those are the 3 zeros. Good. Okay. Well, I'm going to skip number 4. This one's just the same as the other ones. I've got the graph there. I'm going to go on to number 5. This one's a little different, so let me do this one with you. So you know step number 1, you graph it at desmos.com. Find a clear 0 from the graph. So on the exam, what I'll do is I'll give you a snapshot of the graph because you can't go on the internet for your graph, so I'll give you a snapshot of the graph on the exam. So, all right, so where is a clear 0? Well, you can see right here, this is, it's a little bit harder to tell on this one. See how this one is halfway to negative 10? So this must be negative 5. I guess it's not totally clear, but pretty clear. You could focus in better than I did on the Desmos graph. You can hit the magnifying glass and increase the focus, and you'll be able to clearly see that it really is hitting 0 at negative 5. So x equals negative 5, the clear 0. Step 2, we divide now. using synthetic division. So we'll put the -5 out there. And we take the coefficients as 1, 5, 1, 5. All right, and then we bring down the 1 and let the synthetic division begin. Multiply -5 times 1, -5, add them up, 0. Now, -5 times 0 is 0, add them up, 1. And then -5 multiplied by 1 is -5, add them up, 0. 0 remainder, that tells us indeed x equals -5 goes in evenly, so that must really be a 0 from the graph like we saw. Okay, so step 3, that gives us y equals, so what's left there? 1x squared plus 0x plus 1, and remember opposites would be x plus 5. So it's opposite when you put a single number next to x plus 5 there. Okay, opposite of -5. Okay, so now we go to the quad, our friend the quad. So -b plus or minus the square root of b squared minus 4ac all over 2a. Whoops. I messed that up over there. Okay, so what do we got here? Negative, so here's a, b, c, so -b, -0, plus or minus square root of b squared, 0 squared, minus 4, times a, times c, all over 2a. It's going to be a little different here. So what do we got? Minus 0, that's just 0. There's no such thing as -0, it's just 0. Plus or minus the square root of 0 squared, 0. Minus 4 times 1 times 1 is just minus 4. Over 2 times 1, 2. Okay, so what does that leave us? 0 plus or minus the square root of -4 over 2, right? 0 minus 4 is just -4. Now, what do we do with the square? What do we do with a negative number inside of a square root? Do you remember? When you have a negative number, you jump to the front and just right to the front of the square root. Don't let it go past the plus or minus or anywhere else. And by the way, that's 0. You can just get rid of it. It's not doing anything. So it's just plus or minus square root of regular 4 over 2. Do you see that? So a negative inside of a square root, it means imaginary. You can't take the square root of a negative number. Like the square root of 4 is 2, of course, because 2 times 2 is 4. But what's the square root of -4? You can't do it. There's no real life number. What times itself is -4? How could you ever have, you can't have two negative numbers multiplying to be negative, two negatives multiply to be positive. The only way you could get a negative is one positive and one negative, and that's not the same number times itself. That's a number times its opposite. So there's no way to take the square root of a negative number. It's not real. It's not real. There's no real answer. It's imaginary. That's why when you have a negative in a root, we pop out an I. We take the negative out of the root and put an I right in front of the root, because we're saying it's imaginary. It's not real. You can't do that. Okay, so where does that leave us now? So we bring this down to here. It's plus or minus I. Now what's the square root of 4? Just 2. And the root's gone. When you root something, the root vanishes. And then these 2's cancel. So this is just plus or minus I. So our answers are plus I, minus I, and the one we found from the beginning, bring that down, -5. Those are our three answers, which matches the answers they gave us. So what is that? What are these I thought these are the zeros, right? These are the zeros, which means the places where the function the function f of x, or y, same thing, hits 0. Well, look at the graph. Here's the graph right here. It only hits 0 at -5. Nowhere else, right? Here's the line, the x-axis, that's at a height of 0. The only place this function hits at a height of 0, the only true 0, is at -5. It never touches the x-axis after that or before that. It never hits a height of 0 again, right? That's why the other two answers are not real. They're imaginary. It only hits it again in our imagination, not in reality. There's only one real 0. We call that the real 0. The one that is real life, it really hits at -5. The others are imaginary. It doesn't actually have hit at a height of 0 anywhere else. They're imaginary zeros is what they are. But they're still important. You might think that's crazy, but they're still important because they still divide into the original function. They're pieces that go into the original function. They're just not real. They don't really produce a real 0. All right, number 6. Let's try this one. So it's the usual. Step number 1 is to graph it at Desmos, at desmos.com, and find a clear 0. What do you see? Well, this is -1, -2, -3, -4, -5. Boom, right there at -4, huh? Clear. That's a clear 0. And in fact, that's the only place that the graph hits 0. So we know that the other two zeros are going to be imaginary, aren't they? They're not going to be real. There's no other real place. There's no other real 0. That's the only real 0. The other two are imaginary. We can see the answer right there already. They are. See, they both have an I in them. They are both imaginary, the other two. We already know that from the graph. There's only one real 0, -4. So we start with that one. That's the clear, obvious 0 from the graph at desmos.com. Step 2, divide that in there to find the other ones. So we're going to divide the x equals -4 into our function. Let's grab the coefficients. 4, -36, and 48. All right. Bring it down, 4, and let's do our first multiply. -4 times 4, -16. Add them up, -12. Let's do the next one. Multiply. -4 times -12 is positive 48. 48 minus 36 is 12. You know what's going to happen on the last one. You really don't have to do it. You could just skip it if you want to. Right? When you multiply there, -4 times 12 is -48. Remainder 0 again, of course, because x -4 really goes in. It's a real 0. It really goes in there. Okay, so now what do we have? We know our function is, what are the coefficients? 4x squared minus 12x plus 12 and x plus 4. Remember, opposite, whenever you take an answer and you put it in parentheses next to an x, a single number, in parentheses next to x, it's always opposite of the real number it is. So x plus 4. Okay, so we're there. We've broken down the function to these two guys. If I multiplied these out, it would go back to be this original function. We're breaking down the original function and finding the zeros. It's all the same thing. Now, got to do the quad. As you know, it's quad time. Let's do it. -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's going to be, let's see, negative. This is a, b See, negative, negative 12, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay. Simplify two negatives. You know the deal. Positive. Negative 12 squared is plus 144 minus 4 times 4 times 12. Use your calculator. I'm going to use my calculator. 192. All over 2 times 4, 8. And so that's 12 plus or minus the square root. Kind of running out of room here. Maybe I better try to squish it a little better. So this is 12 plus or minus square root of negative, what's 144 minus 192? Minus 48? Right, it's coming out negative in the root. So remember, what do we do with a negative inside of a root? We grab it and throw out an I. It means it's imaginary. It's not real. You can't take the square root of a negative number. So now we bring it over here. We have 12 plus or minus I root 48 all over 8. Now, right, we got the negative out of the root. It comes out as an I to the front of the root. Now, how do you break down the square root of 48? Well, you remember I'll go up here. Square root of 48. That's going to be 6 times 8. That's 2 times 3. 2 times 4, and the 4 breaks down 2 times 2. So 2, 3, 2, 2, 2. So square root of 48 then is 4 is a 3 and 4 2's, isn't it? See them all there? 1, 2, 3, 4 2's and a 3. Okay, and let's ship it out there. So square roots are a 2-for-1 deal. 2 2's inside, 1 2 outside. 2 2's inside, another 2 outside. 2 times 2 outside is 4. What's left on the inside? 3, right? Because that's all that was left on the inside. So, because when the 2 2's send out a 2, they're gone, and those 2 2's multiply on the outside to be 4. So it's 4 root 3. So this becomes 12 plus or minus I times 4 root 3 all over 8. Okay, now, how do we simplify that? Well, remember what we talked about. Any numbers outside the root, you can divide them if all three of them. So this guy, and this guy. Not the 3 that's in the root, right? That's a different world. Just the 12, 4, and 8. Those 3 numbers that are outside the root, because of this Costco glue here, we got to do both of the top with the bottom. So it's all 3 or nothing. Are they all 3 divisible by something? Is there some number that goes into all 3 of those? If so, we can do it. In fact, we must. Otherwise, we can't. So is there a number that goes into all 3 of those? Yeah, 4. Divide by 4 leaves a 1. Divide by 4 leaves a 3. Divide by 4 leaves a 2. I divided them all by 4, didn't I? Let me do a better job on this one here. So I divided them all by 4. So that leaves 3 plus or minus I times 1. Let me write that better. I times 1 times root 3 all over 2. Right? And now let's separate it. This 1, I times 1 is just I, right? Multiplying by 1 doesn't do anything, so I'm going to ignore that. My 2 separate answers are 3 plus I root 3 all over 2, which is the same as this answer up here. If you come up here, this right here, that's the same thing. You can separate that 2 underneath each one, or just keep it as one big fraction. 3 minus I root 3 all over 2. That's the plus and the minus option in the middle. And the answer from the beginning, negative 4. Negative 4. There's the negative 4. There's the 3 over 2 minus root 3 over 2i. There's our three answers. You can enter it either way. You know, one big fraction, or two separate fractions, two separate fractions. It doesn't matter. It's all the same. There's our three answers. That was a tough one. There we go. Okay, so number 7. Looking here at number 7. They want us in the end to, it's basically same thing, find the zeros, but they want us to say write P in factored form. Like you can see the answers right there. They want us to write it with parentheses. That's the same thing as finding zeros. It's just when you put them in the parentheses, you do the opposite, right? Remember, whenever we stick something in parentheses, we do the opposite. So they're just making sure we know how to do that. It's going to be exactly the same process. Let's do it. So step 1, you know. Step 1 up here. You're going to have to graph it at Desmos. Not Desnos, but Desmos.com. Find a clear 0. And you can see right there at 5, that's a clear, and in fact, it's the only clear real 0. It's the only real 0. It's the only place the graph hits the x-axis. And so, therefore, the other zeros are going to be imaginary. We can see that's true, huh? See, the other factors or zeros, same thing, are going to be imaginary. So the only clear 0 is at x equals, well, that's negative 5. I'm going to be a little careful there. That's negative 5, isn't it? Because here's 0, and these are positive numbers this way. Here's regular 5. So that's negative 5. Negative 5. Okay. Step 2. Divide by that negative 5. Time for synthetic division. Let's do it. So, the negative 5 here. Grab the coefficients. 1, 5, 4, 20. So there's the coefficients. So now I'm just going to bring down the 1 and let the synthetic division begin. Multiply. Negative 5 times 1 is negative 5. Add them up. 0. Next step. Multiply. Negative 5 times 0 is 0. Add them up. 4. And then negative 5 times 4. You know what's going to happen. Negative 20, 0 remainder, of course, because x minus 5 goes in evenly. All right, step 3. What do we have? Y equals, so what are the pieces that are left? 1 x squared, 0x, and 4. And this guy, x, and what's it going to be? X plus 5. Remember, because it's opposite when you put it in parentheses next to an x. A single number in parentheses next to x, it's always opposite. So the opposite of negative 5, positive 5. Okay, now it's quad time. As you know, quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. So let's identify our A and our B and our C. So this is A, this is B, this is C. So negative 0 plus or minus the square root of B squared minus 4 times A, which is 1, times C, which is 4, all over 2A. And so what's that? That's going to be negative 0 plus or minus the square root of 0 minus 4 times 1 times 4 is 16. All over 2 times 1 is 2. And so that is, negative 0 is just 0, is just gone. Plus or minus square root of minus 16 over 2. We don't need 0 in the front, right? 0 doesn't do anything, so I just get rid of it. Remember what we do with a negative inside of a root? A negative, you can't square root a negative 16. What times itself would ever be negative 16? Nothing, it's imaginary. So you jump out the I. So what do we have? Then I'll bring it over here. That gives us plus or minus I square root of 16 over 2. And that is plus or minus I times 4 over 2, right? Root 16 is just 4, and the root's gone. Whenever you root something, it vanishes. All right, and then last step, 2 goes into 4 2 times. So plus or minus 2I. So those are the other two zeros, right? It means plus 2I and minus 2I. Now, in the end, they want us to write this factored. So it's going to be y equals, or p of x, whatever, equals, and then they want the parenthesis. Now, you got to do the opposite, remember? So the opposite of plus 2I is minus 2I. And the opposite of minus 2I is plus 2I. And then the last one is the x plus 5, because that's the opposite of the negative 5. So x plus 5. See, we did opposite, opposite, opposite of the actual zeros. Because the actual zeros, right here, those were the actual zeros. But opposite, opposite, opposite when we put them in the parentheses. And that's what they want on this one. They want the parentheses. So it's the same thing. You just find the zeros, then you put them in a parenthesis, each of them next to an x, opposite. So there it is, same thing. Okay, number 8. This is the hardest one in the homework. Here we go. You know step 1 is to graph at desmos.com, get any clear zeros. Okay. I've got the graph for us here, and you can see some clear zeros. Actually, there's a couple of them, huh? So this is 1, 2, 3, 4, 5. So right there at 3. And then right here, this one's at negative 1, isn't it? So we have 2 clear zeros on the graph. X equals negative 1 and x equals 3. Okay, x equals negative 1. Here, let me put it over here. X equals negative 1, x equals 3. And then notice what they say. They say 6i is a 0. So that means x equals 6i is a 0. And here's a special rule that you need to know about. Imaginary, which are also called complex. An imaginary number, a complex number, an imaginary number, that's a complex number has an imaginary and a real part to it. So this is really 0 plus 6i. Its real part is just 0. Its imaginary part is 6. That's a complex number. Complex meaning it's not simple. It's made out of two things, a real number 0 and an imaginary number 6i. So a complex number or imaginary, it's pretty much the same thing. Imaginary complex 0, if you have one like we have one right there, always the conjugate is also a 0. Now, what do I mean by conjugate? Opposite sign on the imaginary, in the middle on the imaginary part. Opposite sign, sorry, I'm getting a little scribbly there. Opposite sign, let's say, opposite sign in the middle on the imaginary part. So if we have 0 plus 6i, that's really how you would write out I mean, you don't really need the 0. Then the conjugate, that's the one we have right here, 6i, which is the same as 0 plus 6i. The conjugate, which means, conjugate always means opposite side in the middle. When we do that in math, we use that for various things. Conjugate means opposite side in the middle. That'd be 0 minus 6i. You just change the sign in the middle. In other words, you change the sign on the imaginary part. So in other words, it's really just minus 6i. The 0 is not doing anything. That's also got to be a 0 automatically. That's what we're saying. Whenever you have an imaginary 0, its conjugate will also be a 0. So if 6i is one of our zeros, which they told us it is, then minus 6i, the conjugate, the opposite sign in the middle on the imaginary part, is also a 0. So we really know that x is minus 6i is a 0, as well as x equals regular 6i, and x equals negative 1 and positive 3. We can see those from the graph. So we already have 4 of the zeros. And this is 5th degree, so there's only one more to go. The degree tells you how many zeros, right? There's only one more to go. So we just need to find that last one, but that's easier said than done. So I'm going to go to a fresh screen where we have a little room to work, taking the information we have. So now on number 8, we have the function p of x equals 3x to the 5th minus 7x to the 4th plus 101x cubed minus 249x squared minus 252x plus 108. It's a big function. And we know that the zeros, we know 4 of the zeros already. What are they? X equals, from the graph, negative 1. X equals 3. X equals 3. I think we put 3 first. It doesn't matter. Whatever order, doesn't matter. X is 3. X is negative 1. And x is 6i. And x is minus 6i. We know those are all zeros. We just have one more to go. So how are we going to find that one more? Well, basically on this one, step 1 is the graph to get the obvious zeros. Step 2 is the divide, right? This is all step 1, get the clear zeros. They gave us 2 clear zeros from the graph. They gave us this 0 by just telling us 6i was a 0, and then we figured out the conjugate. Whenever you have imaginary numbers, then the conjugate, the opposite sign in the middle on the imaginary part, is also a 0. So now we can divide. Divide by what? All of them, one at a time. So here we go. Let's start with, we're going to take these coefficients. 3, negative 7, 101, negative 249. In fact, I probably better space these out. We're going to need a little bit of space here. So, 3, and then I'm going to go way over here. Minus 7, then way over here, 101. Way over here, minus 249. Maybe I'm going a little too far. All right, 101 minus 249 minus 252, 108. Okay, so let's bring down the 3, and what are we dividing by now? We're dividing this one by the by this 3. We'll start with the first one. So this one right here, the 3. All right, so here we go. You know how this works. 3 times 3 is 9. Add them up. 2. And 3 times 2 is 6. Add them up. 107. And 3 times 107, use your calculator, 321. Subtract those in your calculator, 72. And 3 times 72 is 216. Get minus 36. You know what the last step's going to do. I'll do it anyway, but you know it's always going to end up being 0, huh? 3 times minus 36, minus 108, 0. And let's put our wall there. We're going to see that wall creep over. That's the remainder, which means we did everything perfect, and x equals 3 really goes in. Okay, now we have a bunch of stuff left. So we have to divide again. Do you realize we gotta do this again? Let me get these out of the way, and we're gonna long divide here, and here we go. We're gonna actually do it again. This is round 2 now, and now we're gonna divide by the next number, which is -1. So now I'll put -1 there and do it again. So we take what's left over and we divide again. We just keep dividing. So bring down the 3, and here we go. -1 times 3 is -3. Add them up, -1. And then -1 times -1 is +1. Add them up, 108. And -1 times 108 is -108. Add them up on your calculator, -36. And the last step, -1 times -36 is +36. Add them up. No surprise, 0 remainder for that one. See how it's getting smaller, our answer, the remainder is moving over? All right, now, so we've done those two. We're down to this point. We just keep dividing. So whenever we have a 0, we can divide by that 0 and get what remains. So now we're going to go to the next one, which is an imaginary 0. We haven't done that before. So I'm going to divide by that imaginary 0, 6i. That's the next one, right? 6i. So here we go. Bring down the 3. You can do it with imaginary zeros just like you do with everything else. Just got to be careful. 6i times 3. What's 6i times 3? Well, 18i. And then when you combine this and this, they can't combine. One's a real number, the other's imaginary. So just bring them down, 18i minus 1. You can't, they can't make 17 or something because they're different. They're unlike terms. One's an 18i and the other's just a regular -1. Okay, so then do your next step. 6i times, now what's going to happen? 6i times 18i is, what's that, 108i squared minus 6i. Do you see what happened there? The 6i multiplied the 18i. 6 times 18 is 108, and I times I is I squared, and then the 6i hit the -1 to be minus 6i. It distributed. The 6i distributed to both the 18i and the -1. Now, what do you do with I squared? Remember that I squared is -1. That's maybe a rusty point for you. So it comes down like this. Yeah, I squared is -1. See, we leave regular I. See how this 6i, that's just a normal I. We'll leave that. We don't mess with that. I is just I. But the I squared right here is -1. We don't leave I squareds hanging around. I squared is -1. So whenever we see I squared, let me write it somewhere over here. I squared is -1. We always replace I squared as -1 because it is -1. We never leave I squared hanging around. So this becomes -108 minus 6i. That's what goes right here. -108 minus 6i. And then we add this with this, and you see how the 108s cancel, and you just get minus 6i. And then let's do our last step here. 6i times minus 6i is minus 36i squared. Minus 36i squared, right? Because 6i times minus 6i, 6 times minus 6 is minus 36, I times I is I squared. And again, what do we do with I squared? We leave regular i's, but I squareds, we replace I squareds as negative 1. So that'll be negative 1, which is positive 36. This is going to become positive 36. Do you see that? Because it was 36i squared, and I squared is negative 1, and 36 times negative 1, or negative 36 times negative 1, is positive 36. All right, and so what does that make? No big surprise. 0 remainder. That's perfect. We got to get that. 0 remainder. Let me get rid of all this stuff. So we got another 0 remainder, which means that went in perfect. No surprise. They told us it was a 0, that it would go in perfectly. So, okay. So now we have one more 0 we still haven't used. Right? We used 3. Let me get rid of this stuff here. That was 3. We used the 0, 3, the negative 1, the 6i, one more to go. The minus 6i. The minus 6i. So now I'll do the minus 6i, the last 0. This will be it. Bring down the 3, minus 6i times 3 is minus 18i. Add these guys up. 18i minus 1 and minus 18i. These cancel, it's just minus 1. And then minus 6i times minus 1 is plus 6i. Minus 6i and plus 6i, no surprise. 0 remainder again. Okay. After all that dividing, we were given 4 zeros. This is very different, right? Normally we only have 1 0 to divide by. This time we had the 2 zeros from the graph. You know, the 3 and the negative 1. We divided by 3 and negative 1. And then they told us 6i was a 0, so then his conjugate, negative 6i, is also a 0. Divided by all those, just kept dividing. And what are we left with? We're left with this. So now, y equals, this is going to be 3x minus 1. And then for each of these guys, remember we do opposite, so it's going to be x minus 3, and then opposite, x plus 1, and then opposite, x minus 6i, and then opposite, x plus 6i. There we go. There's the factorization that they wanted on this problem. That one was a lot of work. Okay, so let's go back. So now we're on number 9. Number 9 should be much easier. 8 was the hardest one. Number 9, they're saying take that function and divide by x plus 2. So we can do that easily enough. We just put a 2 here, take the function, 7, negative 4, 6, and we'll divide. What are we going to get? Bring down the 7. 2 times 7 is 14. 14 minus 4 is 10. And 2 times 10 is 20. 26 is... Oh, I messed this up. Why is it the wrong answer? What did I do? Do you see what I did there? I messed this up. I wasn't careful enough. I'm going too quick. What was my mistake? Do you see it? Remember, I'm supposed to do opposite. So when they say x plus 2, remember when a number is right next to x plus 2, that means you're supposed to put a minus 2. Anything right next to x, you put the opposite when you do, synthetic division or x equals, right? Whenever a number is right next to x, whether it has parentheses or not, if it's right next to x, that means it's opposite. So let's bring it down. 7 minus 2 times 7 is minus 14. This adds up to minus 18. Minus 2 times minus 18 plus 36. Remainder, add them up. 42 is the remainder. 42 is the remainder, which is the answer they said. All right, so the next one, divided by x plus 1. So that means negative 1, right? Whenever a number's right next to x, whether it has parentheses or not, it's the opposite of what it really is. So for the synthetic division, I got to use minus 1. And again, we're starting with the same function every time. See how they say the f of x, the f of x, the f of x, every time we're dividing by the same function. So bring down the 7, minus 1 times 7 is minus 7. Add them up, minus 11. Start the next one, minus 1 times minus 11 is plus 11. Add them up, 17. 17, that's the remainder. How do you do that third one? We're dividing by x. So what? There's no number next to x. So what number is that really next to x? Plus 0. Just put a 0 out there. Plus 0, minus 0, whatever. Makes no difference. It's just 0. So 7 minus 4, 6. Again, bring down the 7. Here we go. Multiply. 0 times 7 is 0. Add them up, minus 4. It's kind of funny. And 0 times minus 4 is 0. Add them up, 6. So the remainder is 6. Sure enough, that's right. And then how do we do the next one? We're dividing by x minus 1. So again, if a number's right next to x, whether it's got parentheses or not, it's the opposite of what it really is. So plus 1. And write 7 minus 4, 6. Here we go. Bring them down. 7. 1 times 7 is 7. And 7 minus 4 is 3. And 1 times 3 is 3. Add them up, 9. 9's remainder. I'll let you do the last one. It's the same exact thing. So on to number 10. Okay, so on number 10, they want us just to plug some values into a function. You know how to plug f of negative 2 into a function. So I'm going to plug, wait, I should read. You could just plug it in, but see they say using synthetic division. So what they want you to realize here is that plugging in negative 2 is exactly the same thing you would get if you just divided by negative 2 with synthetic division. So let's do it. I just put the coefficients on the inside. We're going to do the negative 2, bring down the 6. Here we go. Negative 2 times 6 is negative 12. Add them up, negative 20. Do the next one, negative 2 times negative 20 is plus 40. 45. Like that. That's the same thing you would get if you just plugged in negative 2. Let's prove it. So you plug in negative 2 to the original function. I'll bring it right here. 6x squared minus 8x plus I'll say or you could have just, here let me erase this. You could have just plugged in, let's see it. So f of negative 2, if we just plugged in negative 2, what do you get? 6 times 4 plus 16 plus 5, what's that? 24. So 24 plus 16 plus 5, 45. Same answer here, same answer there. See, I'm just proving to you that plugging negative 2 into a function is the same thing as doing synthetic division by that number and grabbing the remainder. It's exactly the same. So that's how you'll do all these, just do synthetic division on those. And then number 11, there's nothing new here. I'll just say this is the same as all the other ones. Just do the same thing we did on all the others. There we go.